Presentation will introduce you to Brane, a powerful platform designed to streamline the development and deployment of distributed applications across diverse, geographically dispersed IT resources. The objective of this presentation is to showcase Brane's main features, highlighting how it addresses common technical and organizational challenges that can often impede progress in both scientific and business fields. The Brane framework is the result of 6 years of dedicated research and development, beginning with the EU-funded Process project. Initially developed to support exascale applications on distributed high-performance computing centers, it addresses the complex demands of large-scale data processing. Brane provides a programmable framework for orchestration, focusing on applications rather than directly programming compute procedures. It has been successfully applied in diverse domains, supporting the development of complex data processing pipelines in fields like astronomy and medical imaging. Since 2021, Brane was developed further in the context of the EPI project to enable fast and secure computations across health institutions. The EPI project gave priority to improve the user experience and data privacy and security. As a result, the EPI platform enables data scientists to perform data analyses without having to worry about the underlying distributed data processing execution. The EPI platform's central design tenet is affording the separation of users' concerns in accordance with their specialized roles, namely domain scientist, software engineer, and systems engineer. Brane supports 3 key roles in multi-site application development: system engineers, software engineers, and data domain scientists. Each role contributes to different aspects of the development process, and Brane ensures smooth integration of their contributions. System and software engineers typically focus on enhancing the infrastructure and networking layers, handling tasks such as data transfers, external system integrations, and compute operations, enabling the domain scientists to create data processing pipeline on top of components and infrastructure created by the engineers. This separation of concerns allows distributed teams to collaborate effectively by dividing responsibilities. Individual contributions can be seamlessly integrated to build complete programs, while the modular design keeps source code organized and manageable. Conceptually, the Brane framework architecture consists of 2 loosely coupled components: a programming model and a runtime system. The runtime system serves as a minimal foundational layer with only the essential generic functionalities. The programming model builds on this foundation, enabling the runtime system to meet specific application requirements. At the core of Brane's programming model is the concept of executable packages or functions. A package represents the outcome of an engineer's efforts to encapsulate functionality as an extension to the runtime system. This encapsulation involves explicitly defining how Brane should execute the functionality's implementation, which can be either source code or a compiled binary. All packages conform to the Open Container Initiative image format, allowing them to be fully self-contained with all required files and dependencies included. Brane architecture of programming model. The Brane runtime system offers a minimal set of core functionalities, but can be programmatically extended to meet application-specific requirements. Custom functions or actions can be registered in the runtime system as packages. In Brane, packages serve as carriers for bundling functions, enabling seamless integration with the runtime system. Each package is self-contained through the use of Docker images, which include necessary system dependencies, files, and metadata. Different builders are available for creating packages, resulting in distinct types, yet they all share a standardized interface for functions. Finally, these custom functions can then be combined to create data processing pipelines using Brane's Bakery DSL. Adding new functionalities to Brane. Brane includes a package builder tool that compiles function definitions and target implementations into a cohesive package. Additionally, Brane offers specialized package builders that can automatically derive function definitions from implementations based on recognized specifications. The first builder targets web APIs such as cloud services and function-as-a-service environments utilizing OpenAPI specifications as input. This builder also automatically generates the necessary API client code to handle HTTP requests. The second wraps existing code, the third composes existing custom actions, and the last help to integrate workflows written in the CWL Common Workflow Language specification, marking Brane's initial integration step with workflow management systems. The infrastructure. Brane can deploy application containers across various environments, from a single host using Docker Compose to geographically distributed resources via Kubernetes. Brane can be deployed on local or distributed resources which can run containers. By default, it expects direct access to remote resources. If direct access is not feasible, an additional layer of indirection can be introduced using local services, enabling organizations to maintain full control over their infrastructure. Brane offers multiple interfaces tailored to different user roles. Brane CLI, a terminal-based interface for scientists and software engineers, allowing them to interact with Brane using Brane script workflows. Policy Reasoner interface, a web-based UI specifically for policy writers, supporting the creation and management of policies using Iflent, available in both standard and JSON formats. Brane IDE, a notebook-style interface designed for scientists, enabling them to develop and manage workflows in an interactive, user-friendly environment. Brane supports two domain-specific languages, DSL, Bakery and BraneScript. Bakery languages offer foundational programming constructs such as variables, objects, conditionals, loops, and functions. In Bakery, each function's core syntax is part of its definition, following a flexible pre-in or postfix pattern. The specific rules for this syntax vary based on the function's argument count, allowing for English-like readable statements. This syntax also enables customization to incorporate domain-specific terminology, making it easier for scientists to understand, modify, and reason about bakery code. This code example shows the bakery code of a real-world use case from the astronomy domain. This use case involves the creating data processing pipeline that generates sky maps from astronomical observations. The pipeline requires the movement of massive size of astronomical data, often in the terabyte range, which is captured in Bakery in a single line of code stage observation files. Brane Bakery DSL significantly simplified this process by relieving astronomers from the complexity of the underlying infrastructure. Through Brane's programming model, domain experts can focus on their expertise, encapsulating the necessary knowledge, while research engineers manage the HPC environment. This empowers scientists to efficiently harness powerful workflows without the technical overhead. Thank you for following this presentation. Today, we explored the key components and features of the Brane framework, which not only addresses multi-site technical challenges, but also supports organizational needs through its modular design. With Brane's flexibility, locally developed functionalities can easily adapt to various resources, providing seamless integration and empowering scientists to create and run applications independently, even from Jupyter notebooks. We invite you to reach out to the Brane developer team via the email address provided on this slide for any questions or further discussions. You can also explore Brane's documentation, tutorials, and source code on GitHub to dive deeper. Thank you again, and we look forward to seeing how Brane can support your journey in innovation.